Hello everyone, and welcome to another R tutorial video. And in this tutorial video, we're going to pick up where we left off talking about data frames and indexing. And we're going to wrap up our discussion on indexing by talking about this idea of subsetting based on a value. So we've already covered how you can pull out an individual value using the row and column number, or the row or column name and row number, how you can index multiple values by using the C function and incorporating the different numbers there. But what if you have a specific value threshold that you're interested in subsetting on? Like in this iris data set, for example, if you wanted to get all of the rows that have a sepal width above a certain length, or a certain width, I should say, for example. And that's something you can easily do with data frames. So as always, we're going to start off by grabbing ourselves a clean copy of the iris dataset. And what we're going to do is I want to first demonstrate how you can get subset based on a single value. So again, we're going to call this one SEEP5. And we're going to get all of the rows in the iris dataset that have a sepal length greater than 5. And I'm going to show you two different ways that you can approach this. And it's going to mirror the same two ways that we could index individual values. So as always, you're going to claim the dataset that you want to index, which in this case is the iris dataset, with the brackets to show that we're indexing, and the comma because you always have to specify rows and columns. So in this case, because we want to index based on a value, we're going to start with the rows. What rows do we want? Well, this is going to be something very similar to what we would do if we were setting up an if statement, where we're going to have some logical operator. So in this case, we're going to go for the iris data set, and we're going to go with a sepal length, right, greater than 5. So what this is going to do is this is going to say, from the iris data set, grab me any row that has a sepal length greater than 5. All right, so just to iterate here, it's going to go into the iris data set and it's going to grab any row that has a sepal length greater than 5. And then we're going to leave the column numbers here blank because we want to again grab all of the columns. So if we run this, right, and if we just really quickly do a dim on iris here, dim on iris, you will see that we have 150 rows and 5 columns, just like we expected. If we do a dim on SEEP _5, you'll see that we've cut out a number of them because they have a sepal length of less than 5. Right, so this is the same sort of logical operator that you would see with an if statement. We can put that into an indexing to index based on specific values. Now that's useful, but we can take it a step further and we can index based on multiple thresholds. But before we do that, I just want to just show you that we can get the same answer here using a slightly different syntax. So if instead of using the, what we call a SEP5 alt for alternative, again, we're going to be indexing on the iris dataset. Comma is always important. And so instead of saying iris $sepal length, what we can say is we can say iris indexed at 1 is greater than 5. So what I've done here is I've done the same sort of thing we were doing up here where you can specify the numbers. In this case, I've specified the column here, greater than 5. So if I run this, and then I quickly do the dim SEP5 alt, you'll see that we get the same response. So this is hopefully a little bit less common. Sometimes you will see it done this way. It's a little less readable. I personally prefer to use the variable names whenever I can. It just improves readability, but you will sometimes see it done this way. So we can just sort of keep that there. So that's useful, but what you can also do is you can chain these logical operators together to do some more complex subsetting. So let's say that instead of just greater than 5, we wanted the sepal length to be within a range. So to do that, we'll call this sep range equals, and then again we're going to be indexing the iris dataset with our comma. So what we do is we wrap the whole thing in a set of parentheses. And inside of this, we can chain together as many logical operators as we want. So we could say, grab us the iris sepal length greater than or equal to 5. But if we wanted to do a second one, we just put an and symbol, right? That and symbol, that's the shift 7 on your keyboard. That's going to tell R to do the and operator so that it has to meet both of these criteria. So the second criteria, for example, we could say iris $sign sepal length is less than or equal to 5.2. And again, we'll grab all of the rows here. So what this is going to do is this is going to say it's going to go into the iris dataset, and it's going to grab the rows that have a sepal length greater than or equal to 5, but are also less than or equal to 5.2. And again, because we left this blank, it's going to grab all of the columns. So if we run this, and then just to check our work here, we hit dim set range, you'll see that we've drastically reduced the number of rows in the data set from 150 to 118 down to 23. So that's if we wanted to do the and operator. If you wanted to do the or operator, set range equals, let's say that we wanted everything that wasn't between 5 and 5.2. So we wanted to flip this around. Well, we could do that using the OR operator. So we're going to set the same thing up with our data set, the brackets, and the parentheses. And in fact, we're going to use the same symbology here, $sign sepal length, but in this case, we want less than 5. And we want the OR operator, which is the vertical pipe symbol, and that is the shift backslash on the keyboard. So it's the key that's right above the enter key. And then we would do iris $sign sepal length is greater than 5.2. So if we so if we run that and we do a dim on sep range or, you'll see that we got 127, which is the exact opposite of the 23 that we got from sep range here. So this is everything that isn't between 5 and 5.2 inclusive. So let's just go back through here and make sure that we can break this down and understand where we're coming from. So we're going into the iris dataset. We're looking at the sepal length, and anything that's less than 5, we're grabbing. And then we're also grabbing anything that's greater than 5.2, and that's because we've used this OR operator here. So the row has to meet one condition or the other, not both. So less than 5 or greater than 5.2, and then because we left this blank, again, we're grabbing all the rows. So hopefully that made sense. This is probably the most complicated part of subsetting, but it's really important to be able to understand that. I actually do want to do one more example of just equals. So let's do a set, call it equals, and then we're going to do the iris data set again, and we're going to do that. So we're going to keep this one pretty simple, and we're just going to grab all of the species that's equal to, and we're going to use Setosa. So because we're using characters, we have to do the quotes, Setosa, and again, keep all the columns. So if we run that, I have done something wrong here. oops, sorry, if you're doing equivalency, you need to use 2 equal signs. That's my fault. Run that. Now we don't have any errors, and if we do the dim on set underscore equals, it should come up to be 50, which is 1/3 of the data set. And it does. So again, just to reiterate what this was doing, is this was again grabbing all of the columns, but it was only grabbing those rows where the species was equal to Setosa. So hopefully this makes sense. I encourage you to play around with this concept. This is going to be extremely important as we go through later exercises and later chapters. So please make sure that you have a solid understanding of how to do this. As always, if you have any questions, please reach out, and thank you.